Hello.
Yeah. All right. Hello, everyone. I guess we're getting slowly ready to start with the second keynote of the day. So I would like to ask everyone to come back in, please. So.
Zoom is running, audio in Zoom is working.
Yes.
Everything is fine. People, is the audio working?
Tell us if you cannot hear me. So, participants at the Zoom, if you cannot hear me, tell me.
Thank you. Well, they can hear us. Okay, then welcome to the afternoon session. Everything good and going? Lars, from your side, yes? Everything good? You can just right-click on one of the tabs. Okay, perfect. So yeah, welcome to the afternoon session. Maybe Lars, if you could switch to my slide, which has a red signing. Then, no, you can just mute it here. Good. Do you switch it? Perfect. Thank you very much. Okay, so the next talk is by Siemens. We have Florian Grams and Antonello Pastore, Benjamin Schade, and also Fabian Rhein, who unluckily is not on this list, so I will also change that. Fabian will start. You know him already because he's co-organizing this school. As usual, let us start. Yeah, let me do the CVs first, and then we watch the trailer, and then I hand over to him. So, here's our candidate, Fabian. Dr. Fabian Rhein started at Siemens Technology as a PhD candidate in the Department of Material Design and Manufacturing Technologies back in 2013. After 3 years, he joined University Relations as a strategic consultant and is now shaping the Siemens research and innovation ecosystem. of Munich and Karlsruhe. Inside the Siemens research and innovation ecosystem, he is responsible for collaborations and knowledge interchange with universities like the TUM, the LMU, the KIT, research institutes, startups, and companies. Further, Fabian Rhein is the Siemens technology contact person for the Siemens PhD network and the postdoc at Siemens program. Our second candidate is Benjamin Schade. Benjamin Schade, could you stand up maybe so that the people see you? Perfect. Benjamin Schade did his Bachelor of Engineering in Mechatronics at the Technical University of Nuremberg between 2013 and 2017. He was a student assistant in the Laboratory for Mobile Robotics from 2017 to 2019. He finished his Master of Engineering in Mechatronical and Electrical Systems in 2021. Congratulations. Also in Nuremberg, since 2021, he works as an engineer in pre-sale support at Siemens. Perfect. These are all the CVs that were sent to me, unluckily, but you can say some words about yourself.
Okay, thank you. My name is Antonio Pastore. I don't know what Mark told you about Benjamin, but essentially I'm doing the same things like Benjamin. Additionally, that I'm just doing partly my research master at the Nuremberg University.
Perfect, very good. And I think Florian's CV I also don't have. I don't know, do you want to say something about Florian? Do you know some details about him?
No, we will hand over later to him and he can give some insight.
Then he can present himself. Good. So we have 4 people doing the keynote, which is very good because then you will have some changes in presentation style and so on. And as usual, we have a trailer. So Fabian and I were creating the trailer, and Fabian was telling a little bit what the talk will be about. And you plugged it in. Yeah, so I cannot use it anymore. And no, it doesn't matter. It doesn't matter.
In our talk, we will give you some insights about our business units, our research departments, and opportunities after your PhD, like our postdoc at Siemens. And in the second part, my colleague will show you how they are using IoT and autonomy in an industrial context, mobile robotics, in combination with our Siemens product portfolio.
And that sounds very exciting, and we're looking forward to your presentation, and I hand over the microphone to you.
That's okay. Yes. Good, then let's change the screens. Okay, perfect. So welcome again. Yeah, you heard it. I would like to give you a short overview about Siemens, what it is in actually, and then afterwards my colleagues will give you more insights really about the topic autonomy and Industry 4.0 at Siemens. I mentioned before, short overview, and then my colleagues came up, and if you are thinking about Siemens or what is going on there, most of the time they're asking it's a software company, it's a hardware company. I think it's both. So we need our hardware, we need our domain know-how to improve our software solutions, our IoT knowledge, and then to really bring it to our customers. And you see it's a focused technology company, so this is our definition right now. And I would like to give you now some insights what is going on and where also we are coming from. So first of all, you can see on the left-hand side digital industries. Digital industries, the business, or we have their different business units, for example, factory automation. Our colleagues here, Florian, Benjamin, and Antonello are coming from this business units, and they have, for example, IPCs, so industrial PCs, as a product portfolio, also other edge devices, and really using the data from the shop floor to bring more benefit outcome for our customers. We have further business units there, for example, software or DI software. Software means we have their simulation technologies for simulate your factory, to simulate your machines, but also simulate, for example, your products. If you're thinking on additive manufacturing and you would like to simulate some new devices, would like to improve the topology, maybe reduce the material and so on. You can find such kind of solutions in our software portfolio of digital industry. Then smart infrastructure. If you take a look outside or out, you will find a lot of buildings where Siemens is doing the energy management, for example, so optimize the energy management, but more in an industrial context. It's not your home, it's not your smart home at home. It's more like airports, for example, hospitals, or other buildings more in the in the open sector or more in the industrial sector. Or for example, if you're going to a gym, sometimes also your gym is optimized, the energy there, with Siemens technologies. Another point or another topic is ongoing there is smart grids. So the whole connection between buildings, cars, for example, with bi-directional charging systems is going on here. And also here, the whole optimization of these different smart grids is located in our smart infrastructure department. Then mobility, maybe you had some struggles to the way to Berlin with the trams, with the ICEs and so on. Here also our colleagues are involved since I think 2 years, so a little bit stronger to improve this process, that you can also use the data from the system, from the ICE, to, for example, see really early, should we set up a maintenance of the system, or is it still working? Can we bring it on the street to bring people from A to B? I would like to skip the other two, Siemens Healthineers and the portfolio company. Maybe one interesting point for you also as a IoT affine people, we have Advanta. Advanta is our consulting group. So in the past it was so-called management consulting, and they draw the whole time the big picture to show companies what you have to do, for example, in your factory to come closer to Industry 4.0, so a really automated factory. And I think 3 or 4 years ago they said we have not only to draw the picture, we have also to bring the implementation there. So they have now 2 parts. One is still the consulting guys who draw the picture of the future, but on the other side we have also solution colleagues there. So really going to the shop floor, bringing there the, for example, IoT devices to use the data then on the shop floor, send it to the cloud, doing data analytics and also visualization, for example, for our customers there. So this is Siemens Advanta. And last but not least, I would like to switch also the services, but one is important, the technology department here. This is our central R&D department, and my department is also located there. So we have around, would guess, 1,000 researchers still there around the world. And in our group, we are dealing here with the collaborations with universities and with external partners, so really in an open innovation context. But I would like to tell you more in a few minutes about it. So again, my colleagues here from the digital industry business, so really business or close to the business, and really working with the customers. And here our technology department is more the R&D department, and we are working together with the businesses to improve their technologies, and then afterwards they go to our customers and help them. Here you can see some examples. For example, what I mentioned before, together with Deutsche Bahn, we are setting up at the moment automatic trains, and we also improve their use of IoT, or let's say of data from the shop floor to really bring some benefits for the customer there. And the other one I also would like to go over, because this should be a little bit more interesting for you. So what we have, or what we try at Siemens is we would like to connect all the business units with our technology department, so with our R&D department and colleagues. And that's why we set up in 2018 11, now there are 11, company core technologies. And these are really the focus research areas which we have at the moment at Siemens in our R&D department. And these technologies we are bringing closer to our business units and have a really strong interaction every 2 weeks, for example. And you see 2 of them, connectivity and edge and future of automation, are really close to our summer school today. But also the other topics like data analytics and AI or simulation to twin are really close to your research topics. And the most of the PhDs, I think I mentioned here, 95% really working on this kind of company core technology fields. And what I also said before, we have a postdoc since 2.5 years. So if you're interested, after your PhD to take a look inside the industry and doing there some research, you can also contact me. So we have their 2-year program, and the idea is that you can decide afterwards what you would like to go, perhaps back to university, to studying really your habilitation, for example. There it's also helpful to have some working experience on the table. And then, or on the other side, if you would like to stay in industry, we can also talk about further possibilities afterwards. So here are some examples also from our research departments together with our businesses, where I said, yeah, the company core technologies. For example, industrial 5G. It's not that we were so close in the research of 5G, but we had it on the agenda since 2011, something like this, and had a really close interaction the whole time with the universities, and tried, or what we are doing right now is we are bringing it more and more to the industrial context, more to our customers in their factories, for example. Good. The other topics I also would like to skip, and would like to come back to innovation disclosures. So what you are, or what's really important for us at the company, and to give you some information or what is going on as a PhD at Siemens, for example. Each PhD creates around 5.5 innovation disclosures, so patents, over his PhD time. And this is a really amazing number, and shows also that the PhD is only 3 to 4 years, right? And this shows really that it's really important, that we are really interested in PhDs at the moment, and of course also on postdocs afterwards. And on this context, it's all around open innovation, and you see we set up in 2021, so last year, the new Siemens Research Innovation Ecosystems. And here also the idea is to have a closer contact to universities, to startups, to companies, and of course also to research institutions like Fraunhofer, and to start together collaborations like bilateral collaborations or publicly funded collaborations. And also our colleagues here from digital industry are seeing more and more that it's not possible to solve all the problems itself, so you have to open up, you have to talk with other partners outside. And for example, you're working really strong with the Applied Science University of Nuremberg, right? And then other startups. So for example, this spot is also based on a startup. So really interesting topics going on here. Good. And with this, here you will have a short overview where our research innovation ecosystems are at the moment. You see really worldwide, different partner universities, different ecosystems where we have the universities, but also other partners, which I mentioned before. Yeah, and with this, I would like to hand over to you, that you can give some further insights to your daily business or daily work close to autonomy and Industry 4.0.
The presenter would be great. Yeah. Great. Okay. So, thank you. It's okay. Very fine. Okay, so welcome to our keynote about autonomy and about Industry 4.0. Speaking of customers, speaking of business, like Fabian told us, to give you a better insight where we are coming from before we are telling you our vision for IoTs and for the next years of industrial. We are like in the sales, but it's way more exciting than it sounds like, because we are like the part of the sales directly connected to colleagues like Fabian, to the R&D department. So we are like the step between the customers and between the R&D department. And inside this department, we are trying to accomplish like a small academic research bubble where we combine the needs of our customers just with ongoing research topics from our side and provide it to colleagues in the whole Siemens company. Yeah, okay. So talking about the agenda, we will start about telling you something about the so-called robot operating system, because this is like the major point we are thinking about right now and doing the most research in it. For the people who don't know what the robot operating system is, Benjamin will update you in a minute. After that, we will just think about and talk about what are our intentions and what is our idea behind IoT. because let's say we have a more insight into the customer needs, and afterwards we will talk about our experiences in the field of mobile robotics, because like the topic of this hackathon is autonomy, and our part of autonomy is autonomy guided vehicles, like this small robot here. We'll come to it later in a minute, or our bigger flagship demonstrator headed in the back. So you are really invited to take a look at it. And afterwards, in the second part of the presentation, we will give you an insight about our academic research work since 2018, because we really want to cooperate with all of you. And yesterday we heard a lot about you're partly already working with robots, already working with the robot operating system. We want to share our knowledge, we want to share our academic research environment and network with you guys. So now I'm handing over to Benjamin.
Yeah, thank you, Antonello, for the introduction. And I would like to give you at first a short technical instruction into the ecosystem ROS, which we are mainly using for our academic research topics. ROS stands for Robot Operating System. We are using the ROS2, the newest version. And technically, from the technical side, it's a middleware, which enables easy communication between different programs, packages, or in the ROS language, it's called nodes. And in this way, we can use this middleware to communicate between all these nodes with subscribe, publish, search, and action methods. It also delivers us a lot of open source tools for debugging, logging, and even visualization our programs. We have simulation tools like Gazebo. We have visualization tools like Arvis, where we can see a graphical robot arm and manipulate it in the visualization to set a goal position for a real movement of the robot arm. Then there are a lot of open source software libraries available, and to these software libraries there are also hardware drivers available which are talking ROS, and so it's easy to have this data from many cameras or sensors in the ROS environment and work with this data in your own package, for example. The last point here about interesting point about ROS is the huge ecosystem of a worldwide community which is supporting you when you have problems or questions. They will give you technical support. There are also industrial partners already, like Universal Robots, which delivers ROS drivers for the robot arms, and so on. Hello?
Okay, thank you, Benjamin, for the brief insight into what ROS2 essentially is. I want just to add to the topic about the community that, let's say there are technical steering committees, there's a huge academic background for robot operating system in its first and now in the second version. And let's face it, like the whole industry, especially from our side, our customers at Siemens, they don't like plain text so much. If you show them like a black console, they are starting to sweat. So we thought, what would be the first thing ROS needs to be industrial-proof, to be a product you can involve some customers with it. And the first thing is to abstract all this for us native stuff like high-level programming languages, all this Linux-based horror for some customers. And the first approach was the so-called behavior trees, because the most technical people and engineers in the brownfield, so-called brownfield, the industry outside academia, they are used to work with flow-based programming, or let's say like you have small blocks and you bring your knowledge about machinery, about automation and control electronics, everything together through tools, through engineering tools. And one of that is the so-called behavior trees for ROS2. Currently, it's more or less a tool to orchestrate the Navigation 2 software stack from ROS2, but we are aiming to open it up and to work with it and to like look into it, what we need to provide for customers or for, let's say, people novel to the field of programming to orchestrate something. And what you can see here now is like a really short sequence, really basic, where we use one of our little fellow robots as an example for a traffic light in this demonstration. So what you can see here is a really rudimentary flashing of the robot, but behind it we have already implemented parts, and the whole program is just this sequence where we also have things like recovery, like what happens when our machinery is outside in the brownfield, or what happens with our robot or even our stationary system when some errors occur. So when we're speaking about reliability, safety in the brownfield, these are our initial steps to just cover it up. Speaking of the navigation 2, what I just told you is one big and really popular part of ROS2, because I said some companies are like participating as a technical steering company, and here you can see one of the outcomes is navigation 2, which essentially, like Benjamin told us, you have small app-like nodes from ROS2, like here, for example, on the right side, our known behavior tree. We have our applications to get our sensory, like in LiDAR sensor, and so on, and you have in the middle all the programming and orchestration already done for you, that you can let such a small robot just with small additions driving on its own, navigating, collecting data of your surrounding, just like a novel electric car when you want to drive it autonomously. Now, speaking of behavior trees and navigation, I would like to show you one of our demonstrators. Here you can see one of our basic AGVs equipped with an HMI panel for human-machine interaction, driving in one of our demo centers in Bavaria. You can see here is a bit more behavior tree and a bit more of a graph. In the upper part, you can see just in real time how the robot is seeing its surrounding through a LiDAR sensor, just like that one here in the small robot. And navigating a robot from point A to point B is rudimentary and really simple when you're taking into account what happens when people are getting in there, like safety reasons. Like Linux doesn't care if a robot hits you, to say it in that way. But you can see that the robot can actually see the cameraman as a dynamical obstacle and just navigate around it without human interaction.
Yeah, as you saw, we collected already a lot of experiences working with ROS in the industrial environment. So what did we notice? We noticed that there is a high interest in different customers to use ROS. They get in the industry more and more complex problems which they want to solve, and they get to the border of classic PLCs. So they want a high language programs, or they need complex algorithms which need to be written with high language, and there is ROS pretty interesting for them. We also see it as a great solution to combine the IT world, the new IT world of ROS with the classic OT world of a typical automation guy. The advantages for a developer are high demand on industrial usability. The stuff packages like behavior trees, what Antonello just showed us, navigation 2, and the support of robot arms with an additional very famous package, Move It 2. But we also experienced some problems with ROS2. One big part is here the network. ROS2 is using DDS as middleware, and we experienced that we get fast to the limit of the bandwidth and latency stuff already with publishing image data from a camera. Something like this, what was working under ROS1 pretty easy with compressed data images. In ROS2, it was not that handy. One solution and also problem could be quality of service. Here is the problem that we need to configure every package or every node with quality of service settings, and this is not trivial. Real-time capability is then the last point here, that when we don't have enough bandwidth for a camera stream, how can we have then real-time capabilities? In the usability, there are two problems. The first one, there is no fixed programming language in ROS2. We can use C++, we can use Python, C#, and all the other stuff. So it's not easy for a developer to understand already available packages when they are in a, for this developer, strange language written. When he's a C++ programmer and he sees a Python code, he will probably have some problems to understand his code. Even the intransparent quality level is here a typical open source problem, that you never know which quality offers this package you find on GitHub. Maybe it will run fine, maybe it will just break down after a few minutes, or you have trouble to get it running from the beginning. How do we use ROS in our current HEVs or demonstrator, which is also here in the next room? The HEV, the base of it is called Evo Robot from Evo Cortex. It has mechanism wheels, means that it can drive in any direction, can drive sidewards, can rotate on one position, but frontwards and backwards also. We mounted a robot arm on it, Euro 5 from Universal Robots. Next to the Linux part, controlled by our IPC, is there also a PLC inside in the IPC, and we have here the ET200 SP module, which allows us to communicate with inputs and outputs. We can connect to it different communication interfaces to talk, CAN, bus, or Modbus, and everything what we would like to communicate with industrial standards. On the back side, we have an HMI panel, which had unfortunately a little bit of damage during the travel from Nuremberg here to Berlin. So at the moment it's not available, but we have it here. And last but not least, the HEV is equipped with our wireless charging module. There are two stations, a fixed station which will be mounted on a wall, and the module station in the HEV. So you just need to drive close to this fixed station, and it will charge like your wireless charging on your mobile phone. The concept, how we combine the two worlds of PLC with IT, is shown here. In the middle, we have our Linux system where the complex algorithms are running. There's our state machine. This is the brain of the HEV. There's navigation, there's move it, and all this stuff is mainly running with ROS. Surrounding of the Linux is our PLC as, let's say, safety layer and I/O abstraction. Here on the top we have the safety. On the right downside is the I/O layer, and also the motion layer is pretty interesting to have here real-time capabilities for control loops. Over the safety layer of the PLC, we can include stuff like safety LiDAR scanners to have a safe detection of obstacles. We have a global e-stop, that the complete system will be safely stopped if anyone press a e-stop or any other conditions let the machine signal to stop. We have on the I/O side, we have the different communication modules and even usual digital inputs and outputs. And on the motion side, we have our system toolbox. It's a Siemens product, Simatic C-Move. This allows us to drive HEVs. The navigation, so the brain of the navigation is on the Linux side, but really the control of the drives will happen on the PLC via C-Move. which also includes safety at the end. And then, last but not least, we have in Siemens a huge knowledge of decades about controlling drives and machines. The journey of our OCP HEV is pretty long. It started with a single robot arm on the left top side. This was a prototype, and in the beginning we mounted this as on the HEV, but experienced pretty fast that a prototype is not as stable like a board Euro 5. So we switched it pretty soon to a Euro 5 and included it the system of the HEV. So in the end we were able to move the robot arm. We are also able to navigate with the navigation tool of the IoT bots. Basically, it's the same software running on this HEV like on the IoT bot. And yeah, right. Is here a video inside? Ah, yeah, okay. On the right side, you see the first movement of the robot arm with successful grasping of beer. The future work of this robot. We hope so. Yeah, let's come to IoT bot again.
Thank you, Benjamin. Yeah, of course, we are coming from Bavaria, so an HEV has to grab beer, of course. So speaking of our robots, we talked in the beginning of the presentation about ecosystem, and you can think of all the different and small applications for ROS tool that in the back end and then the software architecture-wise, they are like apps on your smartphone. So especially when we take a look at this LiDAR system equipped to the smaller robot, on the robot running, it's essentially like a containerized application. So you can just take it, it's platform independent, you can just put it on this bigger robot. And this is like the core idea for us with ROS tools that we have like in small, let's say, app store for ourselves in the development. And speaking of development, this small robot initially was the base of all of our academic research, like for bachelor thesis and master thesis, and even for ourselves to get to know ROS, because in the current state of the industry, you just have like heavy lifters, like 3-meter long AGVs. You can't develop on them really good in your office, or corona-wise in your home office. That could be a problem. So this small fella was developed together with the Technical University in Nuremberg, and essentially the naming of the brain, it's the IoT 2050, essentially, and Siemens Raspberry Pi. And around that, we developed this small robot for us as a platform for you. On the left side, you can see even that we have around 50 of these units now, because swarm robotics, etc., and multi-robot systems in the focus of flexible production of collaborative robot systems is also one of our next topics. And speaking about fun stuff, you can see us here are doing some events. Like today, we are doing events to talk to you guys and to exchange our knowledge. But we are doing a lot of validation of our work, let's call it that way. And here you can see typical Siemens. We just arrived at a hotel and just claimed the whole lobby to work with our robots for a so-called RoboCup in Dortmund, here in Germany, in the Rescue League for our robot. We aim to participate in the Robot League for 1 week each year to solve like tasks in a rescue scenario. Like you have Chernobyl, and obviously people can't go there to look at the concrete sarcophage of the old facility. So you need robots to get there, use AI to take a look at valves, to take a look at damage in the concrete, etc. And this setting is like our benchmark for using our Siemens portfolio to evaluate, is it good, is the network product, for example, from our side good, to have like a robot you want to teleoperate for difficult scenarios, just like a fire in a facility or an accident in the chemical industry. So these are our events. for example. And speaking about our research activities, currently we are in the 4th year of doing this part of research with other students, and the main parts and the main students are of course from Germany, but currently we have collaborations with the TU Delft, or in Poland we have a lot of students next year. Also in Czech and in Austria, in Vienna, we have with a technicum a lot of students, and next year also in Italy, in Milan. So our research environment is still growing, and to give you an insight what our research topics are, we have like our robot arms, like the main, or our main task here for you students is the robot arm on the HAV, but despite that we are working on simulation world to scale up our systems, trying, like, before we build 50 of these small units, we of course tried how 50 of them can behave in a shop floor, or even on concrete, or on some rescue relevant terrain. And we are building up like our small toolboxes for autonomous guided vehicles inside our simulation tools. Navigation, localization, I think that's something we talked enough for the moment. You can see here we to add something to our research topics, we don't only use LiDAR systems, which is like the status quo for academia, but we also try out like GPS systems, so that your next pizza is delivered to you by one of our small robots through a GPS system, and drive like 3 kilometers on its own through Berlin and doesn't lose its pizza. On the left side, we also have some safety critical systems, but also AI. And AI is from our side one of the major points with our robots. For example, we want to teach our robot arms to grasp something, but we don't have to teach it our own. It has to have a routine to teach it on its own. Or we want to detect some objects, like in a shop, that a robot can collect groceries for you and determine how I have to grab the piece of chocolate you really want in your basket. So look into the future. We are coming from Nuremberg currently. We have, like, in Bavaria a really big network, namely the Technical University in Nuremberg, and the other universities like in Hamburg or in whole Bavaria, also in the TU Munich, but as said, TU Delft and the Technicum in Wien. And now, from next year on, even in northern Germany with Bremen and even the IWTH Aachen. So we will work in the next year. So for the last steps, I will just hand over to you.
Yeah, it's not that much anymore. We just have here a short QR code for you. If you would like to contact us through your mail, just scan the code and you will have already a formula to contact us if you are interested to work with us together with our academic research team. If you have some interesting topics about thesis, or also for your PhD, maybe there are some possibilities. We could collaborate and have in the end a nice and interesting ecosystem of packages, functions, which we could use ROS in our industrial environment. So thank you for your attention. I will give you a bit time. Any questions? Yeah, please.
Okay, I have one. It is not directly related to ROS, your topic, but more on how Siemens approaches IoT. So when we talk about IoT, okay, thank you. Also, because I don't know, people are maybe following Zoom. So
interoperability, because we have a lot of heterogeneity in this field, different protocols, different standards, and different closed solutions, like not open. And well, you are in Siemens, a company, so I don't know, maybe you have a lot of core business that you do sell and you don't want that to be open, but that increases the heterogeneity in the field of IoT. So how can you understand those challenges of interoperability and open standards in IoT?
Okay, I will answer a question. On the OT side, Siemens is known for setting standards and using them and providing them like for other vendors or you as a customer or user. On the IT side, ROS2 is, for example, exactly our approach to having standardization, which is completely open and participated by a whole community of end users. So our idea is that, in general, not only on the topic side of IoT, that the whole data distribution is set to a common standards. And yeah, as said, ROS2 is on the IT side one of our approaches. On the OT side, in the facilities, we already have it.
If you want, I can also add something, because we have a strong collaboration with Sebastian Steinhorst. You saw him, this professor who also gave a short introduction at the beginning of the summer school. And here we have also really strong collaboration on this topic. And there is a call on our ecosystem page, and I can send you the link, or I can send the link in the whole group, and you can see a little bit what is going on in a research area here together with Sebastian Steinhorst, for example. And he's working really strong with our IoT department, which we also have as one of these company core technology fields.
Yeah, actually, one of the reasons of my question is because I know that some branches of Siemens are investigating Web of Things, like the open standard. I don't know if you heard about it, and they seek collaborations with others. So maybe I don't know if you work with those branches, because I know Siemens is huge.
You mean Cody? No.
No, Web of Things, the open standard for
right.
IoT.
But it's the same collaboration together with Sebastian Steinhorst over the last, let's say 6-7 years. And he gave a talk on a conference in the beginning of the year, and we recorded it, and you can find it in the internet. So I will send it to you. But yeah, right, this is a really strong collaboration with him on this topic.
Okay, thank you.
Sorry, are you from his faculty or no?
No, but I actually work with a startup that has some collaboration with Siemens, and we developed some stuff on the IoT side with them. Maybe we can chat a little bit after it.
Yes, we can.
Okay, thank you for the questions. Any other people wanting to collaborate with us or something?
Well, I saw some people scanning the QR code. I think we will have something in our inbox in a few days.
Good, then. Thanks again. And yeah, if you're interested to talk with us, we are really here over the next days, over the whole week. So you will welcome. Thanks.